Hello all, this is a video answer key to Unit G, Worksheet 2. I hope it's helpful in preparing for any test or quiz you have coming up. You can walk through the sample problem on your own, but I'm gonna demonstrate the solutions to the questions from the worksheet. The first question gives you the reaction of magnesium and oxygen to produce magnesium oxide. The question says you have a strip of magnesium metal with a mass of 3.98 grams. When it is completely burned, how many grams of magnesium oxide will be formed? So it tells you grams of magnesium and asks for grams of magnesium oxide. So we're trying to change grams of magnesium into grams of magnesium oxide, but you can't go straight from grams of magnesium to grams of magnesium oxide. You need the mole in the middle. So we're gonna go grams of magnesium to moles of magnesium. Then you can go to moles of magnesium oxide. Then you can go to grams of magnesium oxide. So if you recall each of these conversions, this is the molar mass from the periodic table. So you just look up the mass of magnesium. So if you have 1 mole of magnesium, that's 24.31 grams. If you're doing this middle conversion from moles of one chemical to moles of another chemical, you have to look at the numbers from the chemical reaction. So you can see like the 2 from that chemical reaction goes with the 2 moles of magnesium. And then this 2 is the moles of magnesium oxide. So you have 2 moles of magnesium will make 2 moles of magnesium oxide. And then the last step of the conversion takes you from moles of magnesium oxide to grams of magnesium oxide. So you need the molar mass from the periodic table. So if you look it up, magnesium, we already said magnesium is a 24.31, and oxygen is a 16. And so if you add them together, the total mass of magnesium and oxygen is 40.31 grams of magnesium oxide. So after you have figured out the equalities and you have identified the pathway, then the third step is to set up the multiplication so that the units cancel. If you start in grams of magnesium, we need to take this equality and make it into a fraction so that grams of magnesium cancel. Now we're in moles of magnesium. So now we can go from moles of magnesium to moles of magnesium oxide by setting up the units so that the moles of magnesium cancel. This one happens to be a 1-to-1 ratio because there are 2 moles for every 2 moles. So even if you forgot this step, you would still get the correct answer. But you do need to show the units canceling. So the unit and the substance both need to be present so that you can show, like, I'm changing moles of magnesium into moles of magnesium oxide because those are different chemicals. The third equality is the last step in the conversion. We know that 1 mole of magnesium oxide has 40.31 grams. After you have set up your multiplication, you should multiply all the way across, and you should get that number in your calculator. And then you should multiply all the way across the bottom. And then when you get that number in your calculator, you can divide the top by the bottom. If you do that correctly, for this problem, you would get 6.60 grams of magnesium oxide. The number from the calculator is a big, long number. It's got a whole bunch of decimals. But since we only had 3 significant figures to start the problem, we should have 3 to end the problem. And 3.599 would round up, 6.599 would round up to 6.60. So the 9 rounds up to a 10, which adds a value to the 10th place, and that's 6.60. Question 2 uses the reaction between iron and oxygen to produce iron 3 oxide. This is one I did in class for every section, so I'll just leave the solution here so you can see it, but I'm not going to talk through it. Question 3 deals with the relationship between the reaction of zinc and sulfuric acid to produce hydrogen and zinc sulfate. So the question says, if you have 8.36 grams of zinc and it reacts with sulfuric acid, how many grams of hydrogen gas are formed. So you're going from grams of zinc to grams of hydrogen, but you got to go to the mole in the middle. If you're going from grams to moles, you just look up the number from the periodic table. So this number would be 65.39 grams of zinc. If you're going from mole of one chemical into mole of another, then you have to look at the chemical equation. And since the number in front of this zinc is it doesn't look like there's a number, that means it's a 1. And then the number in front of this hydrogen is also a 1. So that means that the ratio of zinc to hydrogen is a 1-to-1 molar ratio. The last step is to convert moles of hydrogen to grams of hydrogen. And so hydrogen by itself has a molar mass of 1.01. And so if you have 2 of them, you would have a molar mass for hydrogen gas of 2.02 grams. So the first conversion goes from grams into moles. So the first equality is this one. You got to put grams of zinc in the denominator so that the units cancel. The second conversion changes moles of zinc to moles of hydrogen. And if you set it up correctly, you can see that moles of zinc will cancel. And now we are left in moles of hydrogen. So moles of hydrogen to grams of hydrogen come from the molar mass. So after you do all of this math, you would end up with a long number from the calculator, 0.25825 and more. But since we only had 3 significant figures in our starting value, you should only have 3 significant figures in your answer. The last question asks you to change grams of hydrogen peroxide into grams of oxygen. You cannot go straight from grams to grams. You need these 2 middle steps. Now, the molar mass for hydrogen peroxide depends on hydrogen, which is a 1.01, and oxygen, which is a 16. And so there's 2 oxygens, so that's 32. And there's 2 hydrogens, so that's 2.02. So 2.02 plus 32 is 34.02 grams of hydrogen peroxide. To go from moles to moles, you have to use the molar ratio from the balanced chemical equation. So there are 2 moles of hydrogen peroxide for every 1 mole of oxygen. So we'll put a 1 there. To go from moles to grams, you need the periodic table. There are 32 grams of oxygen, and we've got to go to 2 decimal places, so you should put 0.00. 32 grams of oxygen is 1 mole of oxygen. So then we set up the multiplication so that the units cancel. There's 85.2 grams of hydrogen peroxide. This is the first conversion. So this equality is the first fraction so that you can show grams of hydrogen peroxide are canceling. The second conversion changes moles of hydrogen peroxide into moles of oxygen so that you can show that the moles of hydrogen peroxide cancel. And the third conversion changes moles of oxygen into grams of oxygen so that you can show that those units cancel. After you've set up your multiplication so that the units cancel, you multiply all the way across the top, and then you multiply all the way across the bottom, and then you divide the top by the bottom. The number 40.0705 does end up rounding, so this place value right here gets rounded up because of the 7, and so the final answer would be 40.1 grams of oxygen. That's the work for Unit G, Worksheet 2. These are problems that I'm sure will show up in some form on a test or a quiz. So if you have questions, come see me before you take it. Good luck, everybody.